Welcome to Introduction to Dimensional Analysis, One-Step Problems. So, what is dimensional analysis? Dimensional analysis is a mathematical method that scientists use to convert from one unit to a different unit. It involves something called conversion factors put into a series of fractions, either in a grid form or a literal series of fractions. The font on the fraction forms looks a little different because I'm using the equation tool in PowerPoint, but there's no difference between these two setups. You do, however, need to understand that the vertical lines in the grid form are the same as the multiplication signs in the fraction form. So let's talk about how to do dimensional analysis problems. There are several things you need when trying to solve these problems. The first thing, of course, is what are you starting with? You have to start with something, and that something should always have a number and a unit. The second thing you need is a unit to end with. In other words, what unit are you trying to convert to? The third thing you need is a pathway or map, which I'll explain more about later. The last thing you need are one or more conversion factors, so let's talk for a minute about what conversion factors are. Conversion factors are equalities we use to convert from one unit to another unit. Some that you may have heard of are 12 inches in a foot and 40 miles per hour. Notice I've also written those as mathematical equalities. We can also write them as fractions, which you have to do when using dimensional analysis. Notice the fractions can be written two ways, which means you will need to decide which number and unit goes on top and which goes on the bottom. So let's dissect a dimensional analysis setup. In the setup, you'll notice there are a lot of numbers and units. The very first number and unit, the ones in the top left box, are your starting number and unit. Notice that the bottom left box is empty. The other sets of vertically aligned numbers and units are your conversion factors. In this case, we have two. 1 mole equals 32 grams, and 22.4 liters equals 1 mole. Now look at the unit in the last top box. This is the unit we want to end up with. Once we have our conversion factors, it will be the last man standing, as it were. What do I mean by that? Well, you hopefully remember from algebra that you can cancel out numbers and variables, like x, if they are both on the top and the bottom of a fraction. You can do the same thing with units. So once you've canceled out all your units, the only one that should be left is the unit you want to end up with. If it's not, you know you did something wrong. So what would a dimensional analysis question look like, and how would I actually solve it? There are many different ways to ask these types of questions, but one example is, what is the volume in liters of 20.7 grams of oxygen gas? Notice that the number and unit given are the beginning or start number and unit, and that's what goes on the top left box. The unit that is asked for is the ending unit and should wind up in the last top box. Notice that volume is a type of quantity, but it's not a unit, so it doesn't belong in any of the boxes. There are several ways to actually solve the problems, some of them involving parentheses. But I'm too lazy for parentheses, and I'm definitely too lazy to multiply across the top, write down that number, then multiply across the bottom, write down that number, and then retype them in the calculator so I can divide them. You are more than welcome to do it these ways, but I like to keep things simple. So first, I know that I can ignore the ones because anything multiplied or divided by 1 is itself. Second, I understand that every time I have a number on the bottom of a fraction, I'm dividing by that number. So I would type in 20.7 times 22.4, because those are both on top of the fractions, divided by 32 because it's on the bottom of the fraction. You can add the 0.00, but honestly, the calculator doesn't care. You should write the 0.00 in the problem to keep track of significant figures. And if you're my student, I expect to see it there. The answer, 14.5 liters, is rounded to significant figures. So let's do an example problem and talk about pathways. So the problem is asking me to find out how many meters I have if I'm given a measurement of 456 centimeters. The 456 centimeters is what I'm given, so that's my beginning number in unit. I'm trying to find how many meters, so that's my ending unit. Now, you may have realized that this is a metric conversion problem and be asking, well, why can't I just move the decimal? Well, you could, but if you're in my class, you'd get no points because you didn't show your work. You must show the grid or the series of fractions in order to get credit. You may also be wondering why you can't just set up a proportion. Well, you could, but A, the purpose of this is to practice dimensional analysis, and B, when you start doing multi-step problems, it's totally impractical and takes too much time to do a bunch of separate proportions. As I said, this is a metric conversion. Because it involves a base unit, meaning a unit without a prefix like liters, meters, grams, we know it's a one-step problem, which means I only need one conversion factor. So before I start setting up my problem, I want to make a pathway or a map. This helps organize my information. In a one-step problem, the pathway is beginning number and unit to ending unit. So 456 centimeters to meters in this case. Now I need the conversion factor that will get me there. You may or may not have to memorize certain metric conversions. In my class we do. There are a number of ways to memorize these things, but to make my life a little simpler, I'm going to use 100 centimeters equals 1 meter. Now I have my pathway and I have my conversion factor, so now I can set up the problem. The nice thing about the pathway, and this is especially true when you have multi-step problems, is that the pathway tells you all your top units and the order they go in, and how many sets of boxes or fractions you need. I have 2 units, so I need 2 sets of boxes if I'm using the grid, and by sets of boxes I mean vertical pairs or 2 fractions if you're using the fraction setup. I put the beginning number and unit in the top left box and leave the box under it blank. If you really want to, you can put a 1 with no unit. It cannot have a unit or it will mess everything up. Put the other units in the pathway in the top boxes in order. We only have the meters for this one, but that's going to help us with making the conversion factor into a fraction. The conversion factor is 100 centimeters equals 1 meter. The meter unit is on top, and the 1 has to go with the meters, so the 1 also goes on top. That means the 100 centimeters must go on the bottom. Double check by crossing out your units. Only meters remains, so we're good. To calculate, take 456 divided by 100, because 100 is on the bottom, and the answer is 4.56 meters. All right, now to try one on your own. I suggest you pause when the screen changes and try to do the problem. You can resume play after you finish to see the answer. Here are the beginning number and the ending unit. Here's the pathway and your conversion factor. Here's your work. Here's your answer. I hope this video has been helpful to you. Thanks for watching.